Thank you, Alexander, for the introduction, and thank you to all the organizers of this very interesting event for inviting us to give you some insight into the activities we do in Rostock. So, if before I start, some words about my affiliation. So I'm with Fraunhofer, which is the largest organization for applied research in Germany. We have, I think the slide is a little bit outdated. At the end of the year, we will have some 69 institutes dealing with all kind of technology, medical materials, but also computer science. And we have a lot of expertise in all these fields, and as Fraunhofer, we are strongly partnering with companies to push technologies from basic research to the application. So we are partnering with them in public funded projects, but also doing contracted research to support them with their processes and their products. And one of those 69 institutes is the Fraunhofer IGD. We do visual computing, and this is more or less everything that is related to images. We create images from data, and we create also data from images, and everything around it, including interaction, human-computer interfaces, and so on. And we have 4 locations, and my location is the one in Rostock, so it's 200 kilometers north of Berlin, direct at the Baltic Sea. We have a very nice coastline there, beautiful beaches, but we will not look on the beaches today, but we will look at the infrastructure we want to build under the water. So what we are doing there as Fraunhofer IGD would be a separate presentation each. So the one part is that we do image processing and computer vision, specific for underwater images with all the disturbances and the problems we have in this medium. So we talk about quality improvement there, object detection, 3D reconstruction of structures, for example. And the second research area for our computer scientists we have in our group mainly is visualization of big data and giving insight into really large data sets, heterogeneous data sets. And so I see a lot of overlap with the presentation we already heard from Evangelos, and I'm quite happy to get in touch with him and find out where are some more concrete possibilities for collaboration. So my focus today will not be the research we are doing in computer science, but it's more about the infrastructure and the problem and challenge of testing. Because if we want to have data, we need sensors, and those sensors must be fixed to some maybe a structure that is moored or some vehicle, remotely operated vehicle, whatever. And so we have a lot of technical equipment we have to put into the ocean with all the pressure and the salt and the temperature changes and so on. And if we look onto ocean technology, we see that there are some components, as I said, the sensors, acoustical sensors, optical sensors, or some more simple CTD sensor, for example. If we put technical equipment into the ocean, we have to take care about the energy management, so we have batteries and automation equipment. We have to talk about the vehicles, communication, acoustic communication channels, for example, and these are the building blocks, and then they are typically combined and integrated for complex systems such as a seabed observatory or an inspection ROV, a remotely operated vehicle where you have an operator in a ship and he's guiding the vehicle, collecting all the information he needs. So this is what we see, and if we talk to the people that work on these kind of products, sensors, vehicles, and so on, they are faced with a lot of challenges, as I already said, and especially the last one here on the slide is important because if you put a system such as a seabed observatory into the water and it's on the seabed, then it's not very easy to fix a problem. Then you need a diver, or you need to pick up the whole structure, and you need a large ship, and this is very time consuming, very expensive, and so a lot of work is dealing around the robustness of those systems. And if we talk about reliability and robustness, we need some systematic approach. So typically the companies or the developers start with smaller tests and then going to long-term trials in the sea. You typically start with shallow water first before you go into the deep sea. You have a concept to start with component tests before you put in the whole structure into the water. You first have small test procedures and then go to complex missions. And typically you try to first start with some managed conditions in the lab or a similar structure before you go into the real world. And this means that you need some kind of testing strategy, but you also need a hierarchy or a sequence of different testing environments. So as in many other areas, you typically start with a digital product description, so you can do simulation, things like that. Then you go into a lab where you have a small basin, as we see it here on the image. And the next step, you will go typically in a harbor where you have some protected area, but with more space and a little bit deeper. And then you go to the open sea for sea trials, and then depending on the product, the kind of acquisition system you are doing, going into deep sea trials. So this is a typical sequence, and we are collaborating with a variety of small and medium-sized companies in Germany. They are going into this business, and most of them, they have a small basin. Some of them have the lake around the corner, but then they have a problem, because if they want to have more real-world testing in the Baltic Sea, for example, they have to wait if they have the chance to accompany, for example, Geomar or other researchers with their big ships, research vessels, to go into joint projects with them. But this needs a lot of time for preparation. It's very inflexible, and if you want to go into technical development, then you must be very flexible, and it's a problem to plan such a trip to the Baltic Sea or other areas 2 years in advance. So what we are looking for is a testing facility which is focused on the specific challenges of the developers of underwater technology. We need very easy and direct access for this facility. It must be efficient in usage, so all the logistics around should be more or less provided by service providers, so that you do not need a lot of preparation time. Everything is ready if you come with your vessel to test your ROV or your new sensor. And it's the concept that we have some standardized services and have one organization in charge to provide, for example, a ship and a crane, and maybe some kind of a pool for the data and so on, and everything is linked together and easy to use for the customer. We already started with this initiative some 4 or 5 years ago, and we arranged some testing areas for ROVs or even AUVs. So if you want to test your autonomous underwater vehicle, you can go to Rostock. There we have some license to do this, which is otherwise not allowed in the Baltic Sea, especially in the German zone. And there we have 2 areas, one which is in the harbor, and the other one which is directly at the coastline near the beaches of Rostock, Warnemünde. And there you could test your vehicles, but it's not a fully equipped lab. And this is the next step we want to go. And this is something I want to illustrate with a video. I think I have to start it with a mouse click. Okay. This video was focusing on the test area that we are planning very near to Rostock. There we have some kind of an artificial reef that was initiated by fishery research, and we can connect our lab, our testing facility to this area. And it's driven by the demands of our companies in our area, so inspection of offshore wind structures, for example, or also going to the cable detection and pipeline detection and so on. And this is something where we are now in a feasibility study, and we hope to get a confirmation for funding this or next year. And then we will hopefully be able to go the next step in setting up this structure. So beside this subsea field, we also plan some kind of environment which looks very similar to the cove that we had already heard about in the presentation of Evangelos. So it should be an area where we have a strong collaboration of researchers and developers in the companies, and where we have space available for interaction, and we have some labs also and shop floors to support development and research in this area. Okay, so this is just a short overview, and there will be more time a little bit in the panel discussion, but also in the networking later on. And I would be happy if this structure would be interesting not only for the German partners here, but also for a link over the Atlantic and to collaborate with partners in Canada. We are very interested not only in sharing experiences in collaboration and innovation in this area, but also in joint development and research projects. And I think it's a great possibility here for matchmaking, and I look forward for all your comments and questions. Thank you.
Thank you, Uwe. Thank you very much. So my first, you already bridged over to Halifax with your question. So Hannes, do you see any hands? I invite now the Halifax audience to ask the first questions to Uwe and their project in Rostock.
Any questions? Doug, I see you getting up.
Which way do I look?
The camera's over there, so there's a bit of a profile there.
Yeah, so it's Doug Wallace. Liked the presentation very much. The video was kind of cool. But I'm just wondering, how is the experience so far of Fraunhofer working with Canadian institutions? I'm aware there are one or two, I think, already cooperating or have established sites in Canada. Is that correct?
So I must admit that our institute does not have any concrete collaboration at the moment. Fraunhofer is in the last years expanding on an international level quite rapidly, but I have, as I said, some 23,000 colleagues, and I didn't check in advance what kind of collaboration we have. I'm sure that there is nothing on the level of subsea technology, but we are quite open, and it could be one aspect to set up a Fraunhofer-like institution in Canada, but the first step will be to collaborate on a project level with existing consortia or partners in Canada. We are open for this, and I hope that this could be a starting point today.
Okay, Hannes, Matthias Mück would like to comment on that from here, but before that I would like to ask in Halifax Sheila and Hugald to take already their seat at the podium, and here Peter and Colin to come on the stage. We're a little bit behind time, so I want to make sure. Matthias?
Well, I just wanted to comment to Doug's remark that the Passages project that was presented by Camilla Modi is actually a German-Canadian cooperation with the Fraunhofer involvement.